The section name is some properties of a triangle, but we see only 3 properties. Those 3 properties are namely, the first property, if 2 sides of a given triangle is equal, then the triangle is called as isosceles triangle. You know that or not? If any 2 sides of a triangle is equal, you can say the triangle is isosceles triangle. And in that isosceles triangle, we prove the first theorem. Angles opposite to equal sides of isosceles triangle are equal. Theorem 7.2. Angles opposite to equal sides of an isosceles triangle are equal. Only this is the statement. We need to prove the remaining things. To prove this one, we need the isosceles triangle first. So, we will take one isosceles triangle. Let ABC be isosceles triangle. And we draw that as well. Here I am drawing. Such that I am going to take this AB is equal to BC. And we need to prove that angle B is equal to angle C. Opposite angles of equal sides. How to prove this? First, we will split this triangle into 2 halves by drawing a angle bisector. Draw an angle bisector for the angle A, which intersects BC at the point D. So, I am going to draw an angle bisector for this angle A. That's it. Then it is easier to prove that these 2 angles are equal. Can you guess what? How we can prove? By making these 2 triangle congruent. To say these 2 triangle congruent, it is enough that triangle ABD is congruent to triangle ACB. ACD. Okay. How we can say these 2 triangles are congruent? First, we will list out the common things. We have AB is equal to AC. Why is it so? Because it is given. And any other things common for this? Yes, BD is equals BD. That is a common part. Also, we have the 2 pieces of A, but those are equal because we have drawn the angle bisector. So, angle, yes. Oh, sorry, my bad. AD is equal to AD. AD is the common side. Good. Then angle BAD is equals angle CAD. That is also from the assumption. Okay. Equal parts of A, or else by the angle bisector. Okay. Then two sides are equal, one angle is equal. We have to make sure that the angle lies between these two given equal sides or not. Yes, it is. So by what axiom we can say? By SAS congruency axiom, we can say the triangle ABD is congruent to triangle ACD. But is that what do we need to prove? Then angle B is equals angle C by CPCT. Is that enough for the answer? Therefore statement. Therefore, angles opposite to equal sides are equal. Okay, that is all. Next, the second one. The sides opposite to equal angles of a triangle are equal. Sides opposite to equal angles of a triangle are equal. Using the same thing I am going to prove. So we need to prove the sides opposite to equal angles of a triangle are equal. For that we need a triangle. So we will take, let ABC be a triangle. This such that part no need. And it is given that, or else you can take such that the angle B equals angle C. Now the same thing we'll do. We'll draw an angle bisector for angle A which intersects BC at D. Now it is enough that we can say these two triangles are congruent. So instead of this side is equal, we can take the given angle is equal. The given angles are what? Angle B is equal to angle C, because we took such a triangle. So now we have, everything else is common. Now we have two angles and one side is equal. Whether that side is common for the given two angles or not. I am asking you, waiting for your answer. See whether the given two angles, for the given two angles, this side is common or not. Think well and answer. Think well before you answer. See, these two angles we are talking about, this one and this one, and I am saying this side is common. Are they common sides for these two angles? then what congruency rule we can apply? That is at AAS. By AAS congruency axiom, you can say this. Also by CPCT, we can say AB is equal CAC. Therefore, the sides opposite to equal angles are equal. That is it. Shall I explain this one more time? See, previously we have proved that the angles opposite to equal sides are equal. So, in the question itself it is given that the sides are equal, we need to prove the angles are equal. Now, in this case, the sides opposite to equal angles are equal, which means the angles are already equal. We need to prove the sides are equal. Sides in the sense this AB is equal to AC, we need to prove. Okay. So, we have to write to prove also. We have written the given part. So, we need to prove AB equals AC. So, for to prove this, I am drawing a angle bisector for the angle A, which bisects the angle A, which means two parts are equal. So, in this two parts of the triangle, I am going to say these two are congruent. How to make these two are congruent? So that you can say these two sides are equal. See, the common things for these two triangles, this angle is common because there is bisected parts of A. Okay, and this side is common, AD is common side, and as per our assumption, this angle B is equal to angle C. So we have two angles and one side equal. So it is AAS or ASA. For that, we need to check whether this side is common for both the mentioned angles or not. No. So therefore, AAS is congruence. Also, we need to make sure, see, this side is involved in the arm of the single dotted and noted angle. Okay, not the other one. All the aspects we should check. So, by AAS congruency axiom, we have proved these two triangles are congruent and the sides will become equal by CPCT, corresponding parts of congruent triangles. And we write the result. Therefore, the sides opposite to equal angles are equal. That is it. Shall we move to the next one?